Hi, welcome back, everybody. My name is Todd Smith. I am with our Partners and Alliances team, and I'm super excited to be here this morning to share with you a number of partners that we have within the artificial intelligence and machine learning sector. So from this morning, we have 5 great presentations from several partners: Vision 3, Geospark Analytics, Figure 8 Federal, Descartes Labs, and Geocam. So we'll be getting presentations from them this morning. And as mentioned, we are a little bit tight on time, so we're not expecting to have too much time for Q&A. So please use the chat feature as questions come up in your head. Ask that you put them into the chat window. So first off, we have Chris Mayhew from a partner called Vision 3. Vision 3 is able to convert video into geospatial data, and they're going to be talking about their capabilities and their integration with ArcGIS. So Chris is here to chat about this today, so I'm going to hand this over to him. Take it away, Chris.
Thank you, Todd. Can you hear me?
Yep, loud and clear.
Okay, you got my screens up and running?
Yes, sir.
Okay, excellent. Sorry. I want to thank you, Todd, and the Esri Federal Partner Team for inviting me to speak with you all today. My presentation is on converting video into structured geolocated data. Again, my name is Chris Mayhew, and I'm from Vision 3 Imaging, Inc. We are a Reston, Virginia-based company that specializes in unique parallax visualization and image analysis technologies. We have developed a unique image analysis software tool called V3 Tools. V3 Tools is a mathematical engine that requires no training database to function. It is powered by proprietary parallax induction and image segmentation algorithms, which can be used to analyze FMV, WAMI, space-based streaming, and mobile sensor data. V3 Tools automatically detects, tracks, classifies, measures the speed, shape, size, bearing, RGB color values, and records the geolocation of objects in the sensor data. All the extracted information is saved in a database and or streamed to ArcGIS Pro via TCP or JSON data socket. The database includes an object log that tracks the RGB color values, the pixel XY location, and 34 other attributes of every pixel of every object detected in every frame. The object RGB and XY pixel data can be sent from the database directly to a machine learning application or output as an image chip for training purposes. V3 Tools includes multi-thread detection and GPU accelerated analysis and visualization capabilities, real-time processing scales with the number of available CPUs, and CPU clock speed. We are getting ready to release a specialized subset of V3 Tools called Trafficview that is designed to use streaming video or CCTV to count cars, trains, and people and send that data to ArcGIS Pro in real time. Trafficview is a simple tool that reads roadside streaming camera feeds to detect, track, count, measure, classify, geolocate, and database the extracted vehicle information, while at the same time sending a real-time TCP or JSON data socket to ArcGIS for visualization. Trafficview can read web, standard def, and HD streaming camera feeds. It is a simple way for traffic managers to turn every streaming camera into a real-time data feed. This is an illustration of how a Caltrans streaming camera in Lake Tahoe can be used to detect and identify and measure and geolocate the passing vehicles on an ArcGIS map via TCP data socket. Each of the vehicles captured attributes are passed along to ArcGIS and are available to the user, as you can see. Stuart Rouse is a solution engineer on the Esri transportation team that uses Trafficview data to power a traffic management dashboard he built to visualize and quantify vehicles passing a streaming camera on Interstate 70 west of Denver, Colorado. As you can see, the dashboard allows you to select a particular date. The display auto-tabulates the traffic data collected on that date and visualizes the data in various graphs. Jim Barry is another solution engineer on the Esri transportation team that uses Trafficview data to power a train activity dashboard he built to count and classify railroad cars using a streaming camera to capture trains arriving and leaving the port of Long Beach in California. Switching back to our V3 tools, here is an example of how it can be applied to the analysis of Air Force ISR FMV sensor data. In this example, we have an EO FMV dataset collected at Angus Inlet in Australia in 2015. That is detecting the targets in the video below the purple banner. Let's see, there we go. V3 Tools is displaying the protection or the progression of the detected targets on the ArcGIS Pro map above the purple banner. The next IR data set includes target labels on the detection. V3 writes the target detections on top of the source video display to confirm the accuracy of the detections. The FMV dataset includes KLV GPS data that V3 Tools uses to assign a lat-long position to each target for visualization on an ArcGIS Pro map. The V3 Tools data socket includes object ID, number, latitude, longitude, time, size, shape, RGB color values, object classification, heading, speed, target data that can be instantly accessed by an ArcGIS pop-up. The software also can output segmented targets in real time. V3 Tools can also be used to analyze WAMI data. This example includes WAMI data captured over Kandahar, Afghanistan in 2012. The WAMI imagery frame rate was normalized and stabilized in V3 Tools, which detected and tracked the subject vehicles, assigning lat-long positions to each detection. The extracted data was sent as a TCP data socket and plotted on a 2020 ArcGIS map on the right. This is an example of a U.S. Border Patrol IR video that was downloaded from YouTube and analyzed in V3 Tools. V3 Tools includes the ability for users to add geocoordinates to stationary objects in the video, which will allow the software to define the ground plane and thereby assign a lat-long position to each detected individual. In this case, the extracted data was sent via a TCP data socket, which allowed the individual's movements to be plotted on an ArcGIS Pro map in real time. And you can see here the plots that are happening on ArcGIS over here. As previously stated, V3 Tools can output segmented and labeled image chips of detected targets for AI and ML application training. However, I'm very excited to introduce another capability that we believe will be very useful to AI and ML data analysis. We have recently adapted V3 Tools to send the detected and segmented object pixel RGB and XY data from the database directly to an AI ML application for instant training. V3 Tools data stream will also include the 34 other object attributes measured at each detection. V3 Tools collects the data at the video source frame rate, The output data, though, can be output at the full frame rate or adjusted to a different rate by the user. Finally, we all know that tracking UAS threats is of high interest to those concerned with facility perimeter defense. This video illustrates the UAS threat, albeit it's a bit cartoonish, but nevertheless makes the point. V3 tools can detect and track UAS threats captured by video and plot its XY position in the video frame. However, this data is not sufficient to target a UAS threat. To provide for total facility perimeter UAS defense, we are adding additional target range finding and altitude data collection capabilities. A custom EO/IR camera array is being developed that will provide a real-time day and night UAS detection and tracking data for plotting on an ArcGIS map and for driving UAS countermeasure targeting. The camera arrays can be strategically placed around the facility to provide hemispherical facility sky coverage. We are planning to release V3 Trafficview through the ArcGIS Marketplace on November 16th, 2020. Government users will be able to acquire V3 tools licenses through the Esri sales network. The targeted markets are for Trafficview would be traffic management, railroad management, people crowd management, port authority, shipping container management. For V3 tools, intelligence, surveillance, reconnaissance, sensor data analysis, facility perimeter surveillance, UAS detection, tracking, and geolocation targeting solutions, AI and ML, image chip, and RGB training data generation. And we are now adding microscopic object detection, tracking, and classification. Thank you very much for your time and attention. Feel free to contact me at the following email or phone number if you have any questions or would like additional information on our software tools.
Awesome. Thank you so much, Chris. Yeah, great presentation there. And as mentioned, if you have any questions for Chris, yeah, please dump it in the chat, or please feel free to reach out to him. But with that, we're going to move on to our next presentation. So thank you so much, Chris. Our next presentation is from John Golgazian at Geospark Analytics. Geospark Analytics creates a Hyperion platform, which is an AI engine that automates global event detection. So with that, John, take it away.
All right, to find the unmute button. Hey, thanks. Yeah, thanks for the opportunity to talk to the team here about what we do. And I'm not sure if I want to follow exploding drones, so I think I want to next time ask where I fall in the category here. Anyways, I'm John Golgazian, Chief Operating Officer here at Geospark Analytics. What I want to walk through today is a little bit about what we do from a core aspect of our platform, and then how we developed the partnership with Esri to put our data and analytics out as Esri feature layers available to in the marketplace and to federal clients across the board. So Geospark Analytics, we're a 3-year-old company based in the DC area. Really founded by a combination of folks from defense, intelligence, and commercial security organizations. What we do in general is we have a core platform that we call, and an AI engine that we call Hyperion that automates global threat and risk assessments. We do this through a combination of data gathering. We gather information from across the globe, from news, social media, streaming economics, natural disaster information, information from weather, information from government sources and NGO sources around the globe. We make all that data available in near real time. But what we do on top of that is what is really unique to us. We have built a series of both statistical and machine learning algorithms, deep learning algorithms really, that are looking for anomalous activity in the levels of information across the globe. And when we identify a heightened level of information, we call that thing what's called a hotspot. And then we also analyze that data. That data comes for its impact. So in addition, impact to the stability of that location, both at a country level, a regional level, and a city level. And what I mean by impact is kind of a rating of geopolitical stability, social stability, economic stability, and then natural disasters that we pull together into a single score for that location. And then we do a forecast of where we believe the stability is trending in that area. Is it trending up or trending down? And is it moving outside of the normal levels of stability for that region? So our engine, again, pulls data in near real time from all those different sources, does those analytics to it, things like stability modeling, event detection, geoparsing of the information. We translate everything. We extract entities, individual entities out of that data as well. We put that into an analytics model, and then we push that out into real world as what we consider real world in our platform. Again, about a year ago, we established our partnership with Esri and then connected our API into ArcGIS Online. And now that data that is available in our core platform is also now available to Esri users around the globe. Again, as feature services, and then we have done some custom app development and some custom dashboarding as well. So what are the really different things that are available as the Esri services? Our event models. So the event models are what we term as the data flows into our system, our Hyperion AI engine, all that news and social media. We built deep learning models, they're not keyword based or an ontology based. So we've actually trained an AI engine, or an AI algorithm to understand what are the things that make up a news or social media report or natural disaster information around 8 core event themes. Things like unrest, like conflict, like a disease outbreak, transportation disruptions, travel issues, crime. This is highly customizable. We actually have, again, 8 that come out of core. And then we are also creating 14 new ones. Some of them specifically for some federal users like FEMA and Transcom, and some that will be available across the board in our model. Actually, one of the new ones that we've developed, the diplomacy model, is now available as one of our Esri feature services, even before it gets into our core Hyperion platform. Those are, again, streaming data in real time from news and social media. Then we take that information as what we call hotspots. So for every point on the globe, we identify the normal levels of information in those data sources. And when there's a spike of information in a location that correlates with one of the event themes, we call that thing a hotspot. That's also available now as a feature service, kind of an indications and warning capability. And then, as I mentioned, we take all that data and analyze how it impacts that location. And the algorithms we've built have learned over the course of time that Somalia is unstable and Sweden stable. No big revelation there. But what it does, it looks every 15 minutes to see, are the events that are happening and the levels of activity that's happening at that location increasing or decreasing the normal levels of stability in that location. And then we forecast the trends there. Again, these are available as Esri feature services. Our events broken down by the 8, now 9 with the diplomacy model. As country stability models, as city stability models, we do about 1,100 cities around the globe today. And regions, we've broken the world up into about 8,000 regions, the landmass of the world. We use a GeoHash 3 level and rate stability on those locations as well. As hotspots, and we've also done some special work around COVID. We've taken our AI engine and kind of tuned it to COVID, a little different than what you've seen in other areas. It's over the US, and we've done a county by county assessment of a 7-day impact of the spread of the virus to the underlying hospital systems. That's updated twice a day. Some quick screenshots, and I'll hop into one of these dashboards just to show the information as it comes in. Again, really customizable. we've done integrations of our data into from our AGL account into other AGL accounts at U.S. combatant commands, inside of Department of Homeland Security organizations, inside of Health and Human Services, so the direct connect into those organizations so they can take our data, integrate it with their data, and come up with better value add information than we have alone. So let me open up one of these. And kind of walk through just a quick demonstration of the information. I clicked on a application we built over the European area, showing all of our data, really a demonstrator of how the data can work. So this is just the general information set. So you can see things like the streaming data and news and social media that comes into the platform. I can quickly filter it by things like where is social unrest happening across the continent today. Those hotspots that we talked about, these unusual levels of information that again tie to some type of potential disruptive event. These are all interactive, of course. And with the links out to the core, to the information that drove that piece as well. I'm gonna go actually skip over real quick to a full interactive, comprehensive, what we call a comprehensive dashboard in this sense as well, to kind of show how all that data comes together. So the events that we talked about, again, the things in news and social media that correlate with one of those event models. The hotspots, again, those things that are unusual. The current stability level of every country in Europe. I can also add cities or those regions that I mentioned. So a quick look at those, and I'll hop back over. We'll zoom down in a bit. Kind of the stability trends in these areas as well. Regional look at the same data. And I'll hop back over to the comprehensive look, and let's drive down into Armenia and Azerbaijan, since there's been such conflict over this area as of REITs. You can see as I moved in, each of the countries in this dashboard at least update to show what are the current stability levels of each of these. Again, I can also look at the past trends, forecast of each, and then get down to the actual specific information that's happening over this area. So, conflict reports that are happening, of the breaking of the ceasefire. Again, looking at not just normal events that are happening, but also what are those areas that we call hotspots, those, again, unusual levels of activity in these areas. So you're looking for kind of the needles in the stack of needles in this sense. So instead of just having 200,000 pieces of streaming data to look at, we're identifying on a daily basis, 20 to 50 very unusual events that are happening, again, around the globe. And the full interactive kind of inside these dashboards as well. Close out of this one. Do a quick run through also of actually we'll move on from there from time. Again, how do we market this information in, or who are we, who we work with? We do work with commercial organizations. Primarily, users are multinational corporations inside of their chief security or chief risk officer organizations, travel safety companies. From the government side, we've had quite a bit of growth this year using the feature services as well, across the Department of Defense. As I mentioned, a number of the COCOMs are using the feature services. Department of Homeland Security, primarily in FEMA and CBP, and Health and Human Services as well are using our platform and the Esri feature services. At a local level, we have some. We've signed a contract with our first state fusion center who's using information, and internationally, NATO is probably our largest client outside the US. How do people, come in and acquire this information. All the feature services are available to purchase on the marketplace, just as simple downloads from there. We also recently signed kind of the culmination of some work that we were doing for the Air Force on our core platform. Sorry about that. We recently signed a 5-year, $95 million sole source IDIQ for us to bring our core platform Hyperion and our API and the Esri feature services to the entire U.S. federal government. So, and this is just a task ordering process where literally we can be on contract within hours of an organization identifying a need and identifying funding for that contract as well. And we've implemented this as well, and the Esri services are part of this. And then we've done, again, direct integrations into other Esri enterprises, directly into AGOLs and other Esri implementations. So just wanted to leave with our contact information. We're always looking for new partners to help increase your capabilities with our content and our machine learning models. And also, we always look for new data partners as well. If you have some unique data that you think may be valuable to add to our analytic models, we'd love to talk to you there as well.
Awesome. Yeah, thanks so much, John. A great presentation. Appreciate it. I guess we do have maybe 2 minutes here before we start the next presentation. Anybody have any questions for John in the group?
Yeah, Todd, there is a question in the chat. Can you see it? I'll ask it. So it says, are you currently consuming integrating data from HHS Protect, or are you only running your models against publicly available data?
So for HHS specifically, we're only running our models on publicly available data. Would love to, I'm not sure that, Janelle, would love to connect up with anybody who is connected to the HHS Protect process there as well.
So my name's Dave Cook. I'm the Senior Director for Customer Success at Figure 8 Federal, where I also work as a Chief Scientist. And what I'm here to talk to you today about is why having a machine learning training data strategy is really fundamental to fundamental to making enterprise GeoAI both operational and relevant. And I'm going to do that through a few different ways, but in particular, I want to walk through some lessons learned and some best practices that we've developed on Pathfinder initiatives within the Department of Defense and the intelligence community, as well as to walk through a joint opportunity that Esri and Figure 8 Federal won together, actually prior to us becoming partners with the DOD's Joint Artificial Intelligence Center. The applications for AI and machine learning, probably as many of you know out there as partners, as other folks working at Esri, they're pretty limitless within federal, and nothing succeeds like success. So we want to talk about ways in which things that we've done well, the lessons that we've learned as far as where the opportunity is, and then really how we can pair up with geospatial companies, geospatial partners at Esri in order to really help build out an enterprise GeoAI capability. So I'll start off with a truism that I stick to continually, which is nothing in machine learning moves without training data. Any machine learning model, any enterprise capability for machine learning within, whether it's the DoD, the intelligence community, Department of Agriculture, the USDA, every machine learning model needs to be taught necessarily what to do. So when you think about the things that you're going to want to have an AI do, whether it's computer vision or whether it's enhanced search, those are all things that a machine learning model's got to be taught, and it's got to be taught through training data. Now, in terms of Figure 8 Federal, who we are as a company, we've worked within the training data space for a number of years. We were actually, prior to Figure 8 Federal, we were Figure 8. And if you have on your cell phone a search capability, if you have a nav system in your car, if you have a personal assistant at home, you're probably using training data that was really curated on our platform. And the reason why we have been so pervasive within the market is because we solve a common problem that every AI and machine learning customer, everybody that's really trying to delve into this market in some way, when they're trying to determine either they're in discovery or pilot or prototyping or looking at scaling, they've always got the problem of of training data, and they've got a very key problem with data science. And one of the things that DJ Patil, the former US chief data scientist, said well is that the hardest part of data science is getting good, clean data. It's often about 80% of the work. And if you look at the graph here on the left side of the screen, going from everything that starts with data identification, aggregation, all the way around to augmentation, if you add all those numbers up, those add up to 80%. And what I like to say about Figure 8 Federal is that when you're trying to think about how I'm going to start an AI initiative, how I'm going to start a machine learning initiative, how I'm going to start to use machine learning in order to help do your job better, we get you 80% there from the get-go, because we provide a capability that allows you to have high quality training data at scale, where you can create, curate, and build training data and really make your machine learning capabilities operational. The other thing, though, that we really do that's key is something that's highlighted here by Anand Mulchandani, who talks more about, essentially how a machine learning model can generalize. So it's more talking about how you've trained a data set in order to be representative across a variety of different use cases. But still, ultimately, what Figure 8 Federal is able to do is to build a training data capability that's allowing you to get started. So again, who we are, we're an Esri Silver partner. We're DC based as a company. We've been in the DC area for about 3 years. We have Silicon Valley roots for 15+ years, active top secret facility clearance. We work with AI ML services, engineering and program management staff, all cleared to TS or above. We work in scalable DevOps. We have deep experience working with DOD, federal commercial entities. We work on everything from JADC2, Joint All-Domain Command and Control, Health and Human Services. We tend to say that the messier the data is, the better. Enable AI and ML at scale with expertise in data processing and setting up data pipelines. And we provide, most importantly, a human-in-the-loop annotation service, what we call DAS, or Data Annotation as a Service. Whether it's cloud, it's a secure cloud, or it's a dedicated bare metal environment. One of the things that we like to highlight is, we have both ATOs for NIPR and SIPR, as well as we're cloud native. So we've worked across every gamut of the deployment environment, and we're pretty familiar there. So our current work within the DoD, in particular right now, we've generated over 400 million annotations for several Pathfinder initiatives out there, working on a variety of different data types. In particular, we've worked with image types like SAR, EOI, and IR, and LiDAR, both classified and unclassified use cases. And we've also used machine learning assisted annotation, which is using machine learning on top of machine learning in order to help humans that are in the loop be able to annotate that data. We work on video use cases, full motion video, classified and unclassified, also using machine learning assist, text and audio. And one of the things that's really important is we can actually bring together taking a specific geographic spot on the planet and essentially annotate or create training data around audio, video, and imagery or text tied to one specific location. What that does is it allows for folks that are working in AI and ML to essentially train a model that can do all source exploitation or multi-int exploitation, which is really is pretty powerful and unique. So we're very proud of the work that we're doing within the DoD. But I did allude to early on here about our work with within the Joint Artificial Intelligence Center, which is really a standout use case of how Esri and Figure 8 work together. So what we did in this particular use case is that the Joint Artificial Intelligence Center, the JAIC, was interested in a capability that allowed for geospatial exploitation, that allowed for model training, that allowed for data annotation at scale. They were looking for a platform that accomplished both the training data task and the geospatial task, and really on an enterprise level. And so what we were able to do is pull together a very compelling presentation as part of our bid to the JAIC that used our industry standard APIs along with some scripting using Esri's JavaScript API and Python to integrate web access, or the web app for the web app builder, along with portal capabilities, and essentially took and created a very loosely coupled system where someone was able to work using the web to be able to fire off training data jobs. They were able to, if you look on the left, you can see working with that, able to select a set of data, have that data sent to Figure 8 Federal's platform via an API call. It sent out data to be annotated and labeled. We'd already set up templates that allowed that to be done easily. That data was then annotated and provided back, again, via web. There was no interruption of the workflow, and those were brought back in either transactional format, or they could be brought back in batch. And it really leveraged a lot of what we do best, which was, how do you not interrupt the workflow? How do you let the GeoEnt analysts do what they need to do? How do you let annotators do what they need to do? We're really highlighting the best of our capabilities. We also brought together one of our, if you see on the right-hand side, our workflows capability, which is really unique to us, that allows data annotation jobs to essentially be chained together. It's a difficult process, and so this allowed us to really automate that. You know, and this is what our successful solution was, how we brought it together. We integrated best of the capabilities. We took a very data science lifecycle approach, bringing together notebooks, Python scripts, machine learning models, web app builder, AGOL. All of that was brought together where we provided some API keys, created a prototype for rapid deployment roughly in about 3 days. And it provided a lot of enhanced human-machine teaming with just a lot of minimal disruption. It leveraged our qualifications across federal. So, you know, we have our strong quals within the DOD and the IC. Esri obviously has strong quals there as well. And it supported a lot of necessary adaptation because we were able to do this in a cloud instance. We were able to tweak and make things move very quickly. I'll just give a couple of quick examples also of our active use cases with machine learning assisted annotation. We pioneered some really interesting capabilities across DoD as far as how do you use machine learning on top of machine learning to assist humans in annotating data. You can see here on the left-hand side some of our work in text. You can see on the right some of our enhanced capability within LiDAR. But just using machine learning on top of machine learning, we've really been able to see about a 51x improvement in overall annotation. And the last piece that I'll just highlight here really quickly is this is our general approach to some of the ways in which we create and curate and build machine learning training data. The things that I think are really important here that I'll highlight at a high level are, this is our platform where we, you know, as if we move from the left to the right, as data is brought to our platform, one of the things that I like to note about how data is curated with us is data always stays exactly where it is. We put web servers on top of data, but it stays at rest. When data is annotated in our platform, it's rendered within a browser and shown within a browser, but once that's done, it goes back to where it was originally. So no data lift and shift, whether you're working in cloud or on bare metal. Really important in terms of security, in terms of privacy, in terms of customers' ownership of the data. As it's brought in, we spend time working on the data design steps, where we have a lot of templates that are very easy to allow you to get up and running very quickly. We have annotation management tooling that allows for very specific kinds of use cases in computer vision or in full motion video, or those two together. We do a lot in terms of job optimization, and we have a lot of quality control built into this, which uses things like redundancy, trust scores. We use randomized test questions to make sure that people are labeling the data accurately and you're getting high quality training data overall. And then at the end, once someone is working within our platform, you're getting your structured data. But I like to emphasize again that we are never a solution that really wants to be out front. There's nothing incredibly glamorous about what we do, but it is incredibly important. Machine learning won't go anywhere without it. And so we are a really good back-end solution in order to solve that issue of how do you get good training data in order to make your AI and machine learning opportunities both relevant and real. So with that, that is pretty much the things that I wanted to cover. This is obviously my contact information, and we have some interesting learnings from our best practices in data preprocessing and data engineering AI ML guide if there are other questions around that. And that's it.
Thanks, Dave. Yeah, awesome presentation. Thanks so much. And as noted, yeah, please note Dave's contact information here to reach out to him with any specific questions. But yeah, two questions did come in for you, Dave. One question asking about ag. Specifically, are you able to elaborate anything you're doing at USDA?
Yes. So we don't. We've leveraged some data from. We've had customers that leverage data from USDA. We are not currently working with USDA. I will say though that the work that we've done on the computer vision side and some of our commercial work related to precision agriculture, we've got some really strong examples of where we've been very successful with customers in precision agriculture, and that's particularly related to targeting using imagery to target where pesticides can be put in at very hyper accurate places so that it doesn't disturb the rest of the environment, and how you monitor quality around that. So that's one use case that I'd be happy to talk further about where we can be really helpful.
Awesome, interesting. Yeah, I guess the next one, any focus on social media or OSINT data coming into your platform?
Yes, that is a use case that we do work on. We have worked on some particular use cases at the DOD where it is harmonizing geospatial combined with OSINT data, and that includes social media sentiment. It includes other kinds of text. It includes imagery brought together as well. So those are use cases that we're actually really strong on. A number of the platforms that you work on, a very large social media platform, we curate the training data to moderate those feeds. So yes, we're very familiar working both in classified environments and unclassified in that use case.
Thanks so much, Todd. I appreciate the opportunity to be here. Descartes Labs is extremely excited about the opportunity to partner with Esri. My name is Ryan McKinney. I head up all of our partnerships for Descartes Labs. So what that means is all the data partners that we work with, as well as the channels and the go-to-market partners as well. So we believe that the future for us is in line and properly aligned with Esri. We know that tighter integration with Esri's products and services is absolutely going to benefit our mutual customers. And so by putting Descartes Labs global scale data analytics outputs into the hands of ArcGIS users, it's really what we want to be able to accomplish moving forward. So we're super excited about it. Let me just make sure. Yeah. So just briefly about the company. Our roots are deeply embedded in science. Our founders and the technology were pulled out of Los Alamos National Lab back in 2014, and the purpose was to enhance real-world decision making by incorporating incorporating geospatial data at scale as part of that, with machine learning as well as distributed computing. We use some of that same Los Alamos technology that was used for global military activity monitoring now to understand the world's physical events, what's happening in this world. But and obviously we have applied science teams that help us build custom models for our clients. And when they're doing that, they're using the access they have on our platform to this planetary scale data. But quite honestly, the piece that's most important to the partnership for us is what's highlighted in green there. We feel strongly that the ArcGIS identity, for example, is going to be a major part of this for us. The ability to get this planetary scale data and the analytics that comes from that into the hands of the users that need it most is really what our key objective is going to be here. And I think will benefit not only our end user customer, but obviously the partnership and our collaboration as well. When we look at our types of customers and the people that we focus on, you'll see there's one here that's highlighted that isn't like the others, and I'll explain why. But I think when you look at what we're doing for customers, and when we mention that we have petabytes and petabytes of global scale multimodal data available on the platform, sometimes the question is why? Why do you do that? And there are three main reasons as to why we're doing that. One being efficiency, and in fact, Dave Cook hit on this. And one of the main issues when you have data scientists and analysts that are trying to do work, they spend a large portion of their time just getting the data ready to do something with it. So because we have all this data normalized, completely ingested, normalized, and cleansed, it's science ready. That's a big value to the customer base that we support. I mentioned a couple of different things here. We have mining customers and energy customers that have seen massive reductions in the amount of time it takes for them to do their initial exploration efforts. So when folks have had to go from 6 months when it comes to target mapping for minerals down to 6 days, that's quite a significant savings, not only on time, but also on money. 85% reduction in geoanalytics prep time. These are tangible ways that, because all that data is sitting there and ready for science, that folks can actually benefit from that. Another added value to that is the fact that when the data is there and it gives you the opportunity to look at a whole host of different scenarios, and one of those being an advanced tipping and queuing capability. You know, it starts to leave things open at a much larger scale, such as global INSAR or other sort of applications that start to unleash new use cases and new ways to integrate and work with that data. And then finally, you know, the third element that's a big part of our value prop is the ability for our customers to build global derivatives and a global derivative data set that's a foundational element to enhance the analysis as it moves further down the path. And these are the key elements that our partnership, we want to be bringing that capability into this. For the one customer that's listed on this site that is not like the others, one of the things I think is interesting to point out, when we're working with our enterprise grade clients, typically we're looking at things like global supply chain or you know, price forecasting, market forecasting, crop yield. These are all the types of use cases that we get embedded with. Well, when we start to put that through a government lens, it starts to become a global input for food security or water security. So we become another element to that overall analysis that our government customers are on, and we're excited to support them on those efforts. Planetary scale modeling using machine learning, petabytes of normalized multimodal data. That's our core. That's what we bring to the table. None of these, everybody on this call has seen every single one of these use cases before. We're certainly not pretending that we revolutionized and come up with these ourselves. But what we do know is that we play a foundational element to this, and we also understand that our customers seem to have a unique delivery system. And the key for us to help these clients move off of legacy systems and emerge into cloud-based architecture, I think we have a real opportunity with the tighter coupling between Descartes Labs and Esri to help those clients migrate from those legacy systems and fully take advantage of the scaled computing, the global capabilities that we provide, along with the enhanced features that come with, you know, with ArcGIS Pro. And so we want to help build that migration and incentivize customers to understand the values of those features that are available there. The way we envision this working is really to focus on DL's real-time global scale provisioning of data and imagery, along with the advanced capabilities of ArcGIS Pro. We're beginning to have and we're moving in this direction now. These conversations we're having right now with our existing customer base, we're talking with folks at the Air Force and NGA and others, and we'll continue to gather that information so that we make sure that that integration is really meeting the needs of our mutual customer. How we're integrating. I think I mentioned earlier, we're very early in this process. I think we've only been, the partnership is certainly in its infancy, but we're already looking at what this integration path needs to look like. We want to do this not in a silo. We're not doing this by ourselves. We're doing this with feedback from our customers. We want to do that in collaboration with Esri so that we make sure we're driving this capability all the way through the process, and the customer ultimately benefits from that. We want that focus, to be around helping access massive data repositories, not only for visualization, but also for added analysis and bringing that at scale and on demand. Our intent is really to listen to our mutual customers and do that. And what we want to be able to provide them is access to this scalable planetary data efficiently and make it scalable and make it effective so that it's able to reach out not only to our federal customers, but also our mutual enterprise customers as well. I think right now, if you look at what we have, the integration with Esri, along with the support and the services, really benefits our key stakeholders in a couple of ways. And I think we can all agree, when we're working with our federal clients, we want to help them achieve their mission. We want to be part of that mission success. The way we can do that is provide our capabilities in the platforms that they want to use. Our customers today are doing this type of work, but our customers today are also working with Esri. So it makes a lot of sense for us to make this work together so that we can capture that business and continue to grow. And also, I think we can all agree it also brings a level of stickiness to this as well. So I think we all have an opportunity to do this. With the fact that we have a lot of customers in common, they're all extracting insights from geospatial data. But we also, from us, and we also understand that that's only one part of a much larger process. So we want to be able to support that better with tighter integration within Esri. Where we are focused today, well, I'll start in 2016. This is really where we started working with the government and decided to make that a major focus for us. We cut our teeth on a couple of small projects with the DARPA MENA project and DARPA GCA. We took those lessons learned from that process, and believe me, there were many, and turned that into small projects within Air Force, and one transitioned into the NGA, and now we have work that's ongoing with AFRL and Space Force. We've made a solid foundation to continue to grow, and Descartes Labs will continue to invest resources, hire more as we start to ramp up our federal practice. And as you see into 21, again, we're looking at the IC expansion. We have work that will start to show up from the combatant command side. All of these customers have Esri in common with who we're working with. So this is an incredible opportunity for us to provide an enriched feature set to the end user customer, and getting that insight into the folks downrange that really need to have access to that. So I think right now I'm going to stop there. If there's any questions, I'm happy to answer it. But ultimately, we're very excited about this, and we're really thankful for the opportunity to come and speak to you all today.
Awesome. Yeah, thanks so much. Thanks so much, Ryan. Great presentation there. And people on the call here, please take note of the email addresses here if you want to be able to reach out directly to Descartes Labs. Be a great opportunity to do that. We do have about 2 minutes here before the next presentation. Anybody have any questions? I guess one did just pop in. Your workflow slide mentioned DHS. Ryan, any explanation on or broader explanation on what you're doing at DHS?
I think that work, actually, to be quite frank, I'm not sure which organization that was with or where. I just know that those are part of the work that we've done that may have actually been done with some of our integrator partners. But I'm happy if there's more interest to find out, I'm happy to go and get more detail on that.
Great. Okay. I'll pass contact information over to you then, Ryan.
Great.
All right, good. Without hearing any other questions, yeah, thanks so much, Ryan. Now we're going to get on to our last presentation here for this session. Excited to have Miles Sutherland from Geocam here today. So Miles is a partner of Esri and knows Esri quite well. And here to talk about Geocam, which provides on-demand and aerial and street-level imaging for mapping services to be used within ArcGIS. This is a great way for content to be brought into ArcGIS so that AI and ML processes can be run on top of them. So Miles is going to be discussing that here today. So with that, Miles, if you can take it away. Thanks.
So really excited to be here today and share a little bit about the work that we've been doing at Geocam. And as Todd mentioned, a lot of this does relate to the roadmap and some of the wonderful developments that are happening around machine learning inside of the ArcGIS platform. So I'll just give you a little introduction to us. We'll talk a little bit about what's going on with machine learning integration points. And then I'm just going to highlight some of the work we do in the disaster response space, because I feel like that's a pretty current topic, and there's some really exciting things happening in that space around data and helping people respond to these events more effectively. Okay, so Geocam itself is founded about 4 years ago. Myself and a couple of friends decided that there may be a future state coming where a lot of machine learning, particularly the computer vision aspects of it, would evolve really rapidly around photogrammetric techniques. And it was awesome to hear Dave Cook speak a little bit about the work that they do in providing kind of tagging type capabilities and helping create models. So we'll touch on that a little bit later. But before we get to that, one of the key sort of foundational layers is how you go about creating and collecting high quality imagery that also enables really accurate location data to come from it. And so Geocam's really invested in building really small camera systems that we deploy both from an aerial perspective on planes, for example, with Cessna 172, 182 platforms that we can use anywhere in the world. Street level collections, we put cameras on vehicles, or more recently, the capability to seamlessly go outdoor and indoors using tiny little cameras to produce this sort of foundational base imagery. Inside of the core of our business, we're actually applying a lot of different machine learning technology that helps us process and deal with the sort of scale and the volume of the imagery. It helps us work on the resolution of the imagery. It helps us work on the position and orientation aspects of the imagery, which is really, really critical. Today, we operate as a bespoke data services company, so we get tasked to go out and collect data with our technology. We go full end to end, so we do the flying and the driving or the walking, the processing of the data, and we'll do all of the sort of final feature extraction to make the imagery and the extracted data, fit directly into the ArcGIS platform. I think moving forward, what you'll see from us is a lot more deeper integration that allows you all to be able to apply some of the new machine learning models that are being developed by Esri or its partners, or models that you develop yourself to be able to work on this type of content. Okay, so just want to show you what's possible these days from this imagery. You're probably familiar with this from UAS systems, where you see a lot of 3D reconstruction happening. We develop sort of similar image processing technologies that lets us reconstruct 3D point clouds. This is a 5 centimeter resolution 3D point cloud of a city that is coming from our tiny little camera running off a Cessna. So the scale of what you can collect is much, much larger than what you might be doing with some of the smaller UAS platforms today. We also get into sort of integrated analytical workflows, so starting to fuse in the sort of raster-based point clouds plus the vector data and enabling analytics. This is some of the work that we do in the electric utility space, specific to the fire response and vegetation management. But what's amazing about everything that's happening today is the ability to not only do this in the two-dimensional space, but also apply machine learning into the 3D space. As I mentioned earlier, not only we thought about this problem from the aerial perspective, we also looked at it from the street level perspective and the indoors. We have the capability to turn on these kind of rapid street level, we call them streetscapes. It provides you the imagery seamlessly kind of fused into the ArcGIS APIs, and it has the ability for us to extract out data that then goes into feature services and other capabilities. We often get the question, like, how does this work? Because we're using such small, low-cost cameras, it can seem a little magical. Most of these systems today that people use in the market use really high-end laser scanning, LiDAR-based systems. They have high-end GNSS systems, IMUs, and on vehicles, often an odometer. You start talking about, you know, hundreds of thousands of dollars worth of equipment that goes onto a vehicle, whereas we're using a little camera that's sort of single-digit thousands to make and operate. So it's a whole different kind of class of what you can do in terms of deploying scalability of the capture. And one of the outputs of this is the ability to create these 3D point clouds. So this is a imagery-based street level point cloud. You saw the aerial one earlier. This is an example of what we create from the camera when it's either being walked around or on the vehicle. And, you know, these data sets are improving continually over time. There's still some noise in these things. There's still some slight differences to what you see in the laser scans. But in general, you know, they're a great data set to be able to create a lot of interesting 3D content. I'm just going to switch over and I'm going to demonstrate some of this to you. So hopefully this all works well. What you're seeing here is the end result of this process. So once we deploy our cameras, in this case, it's a street level collection. We're out driving around collecting this imagery. We all stand up and host a sort of fused imagery viewer that works seamlessly with the ArcGIS web maps, or it'll work with an ArcGIS web scene, which is what I'm showing here. So on the left is where the vehicle's been. All these kind of red triangles represent the shot positions in 3D. And then, because this is just working in a web scene, we can go turn on some of the data layers that we've extracted out of the images. So in this case, where we're collecting, you know, asset level data, point features. Today, this work was done manually without using machine learning for the feature extraction, but that is evolving really quickly. And then on the left here, I'm going to be able to go and turn on a point cloud. So like I showed in that screenshot before, now we've got a 3D imagery point cloud that's been created from these cameras, and I can go down into this scene. So I'm now seamlessly able to view in the imagery what was collected from the camera. I can see the features that were extracted out of the system. In this case, we're mapping street level infrastructure. This was actually a 5G project that we completed in Brooklyn, mapping the light bulbs. And we also got these 3D point clouds that are seamlessly fused in. So this is what we end up delivering today. And as you can imagine, a lot of this is automated through until it comes to the final feature extraction. Historically, we've been doing a lot of that feature extraction manually. This is why some of the work that Esri is doing now around, you know, deploying models and images that I'll speak to in a second is getting really exciting. Okay, switching back into this. And yeah, we go in weird and wonderful spaces. So we can take the cameras in and operate, as I mentioned before, in indoors and places like substations and other areas that you wouldn't traditionally think of necessarily just using photogrammetric techniques. Okay, so let's talk a little bit about the machine learning side of things. We think about the way that we work with the ArcGIS platform from three perspectives. There's the kind of integration side of the house, like how does the data integrate? I've just sort of demonstrated some of that. There's the machine learning models and the inferencing that occurs. You know, where does that run and how does it operate? And then there's the results. This is where the insights are generated. Operations, you know, starting to leverage this data. You're all very familiar with the dashboards that Esri's developed that consumes a lot of this content. Okay, so I guess what I figured today would be interesting and valuable to talk about is the three areas that we see the data management system that's part of ArcGIS playing a huge role in the integration with the machine learning models and engines. So the first for us is that, you know, we're collecting data from planes and cars, and we're processing it, and we're generating these images, right? They're really precise position and orientation. And yes, we can reconstruct them into 3D, but there's also some simpler things that you can start doing straight away with this to get value from the imagery itself without having to go into the full 3D environment. So one of the things that we do is that we will actually push out the data from the images into feature services, and we will snip out photographs as effectively like attachments. So very similar to what you might be familiar with when you're using a mobile phone or a collector application. Someone's out there with a phone snapping photos. That data goes into a feature service. From our system that's going from planes and cars, we'll do the exact same thing. And the reason we do that moving forward is that there's a lot of places that you can apply machine learning models on top of those images in particular. So Esri's investing a lot around, how to work with feature attachment images and run machine learning on those, particularly the computer vision, to then update data in their feature service. And I'll speak a little bit to that in a second about the damage assessment workflows. The second is the oriented image catalog. This is a really interesting development, an area that we support and we enable our data for. This allows a whole host of ArcGIS applications to be able to deal with oblique imagery coming from planes, nadir imagery coming from planes, 360, some people call it bubble imagery, or 360 spherical imagery coming from cars, or maybe even indoors. And that service then enables a whole host of different ArcGIS apps to be able to seamlessly view and work with that imagery, including being able to deploy it inside of the notebooks and run inferencing on top of those images. The third area that's getting invested in, which is probably one of the more complex areas, is in the web scenes. So we will produce those 3D point clouds or a textured mesh. The one at the bottom you can see here is a 3D textured mesh that we create during disaster response service that we run. This is actually showing down sadly a burned down property from the campfire. But there's some really interesting developments and work going on in this area to sort of classify or segment and classify objects that are in these web scenes. And that's an area that Esri is investing in as well. So when we think of how does our system seamlessly integrate, these are the three areas. Can we power imagery and data into the feature services? Can we support the oriented image catalog? And can we support the 3D reconstruction area with web scenes? Okay, so disaster response. Our company today has done a little bit of work over the last 4 years working on different disasters. We deploy the plane capture systems and the vehicle capture systems. We collect imagery. And in this space, it's all about speed. It's less about accuracy. So we look to deliver imagery on the same day. And one of the things that we do is we look to make it seamless inside of ArcGIS so that many people can make inspection workflows happen remotely. They don't have to deploy folk on site in massive amounts of teams inside of evacuation areas. They can work distributed across the country, in a safe environment of their home or office, performing damage assessments. This is the area where the machine learning aspects of what Esri has been investing in is getting really exciting. You might have seen a year or two ago, there was some demonstrations of this capability happening related to the Woolsey fire out here in Los Angeles. Some of this was also used in the campfire and some of the different events that have happened this year. So in this space, what we're doing is fusing all the imagery sources together, blending them in with parcel data sets, and we're actually able to clip out specific parts of the images, push them into the feature services, which then lets the machine learning system run on top of that to determine what level of damage has occurred. One of the things that we're focused on, and I think Dave spoke to this earlier, is a huge challenge to how you create training data. And one of the best ways to do it is to create a feedback loop on this. So when machine learning system is determining the level of damage that's happening on a property related to a fire, or maybe it's a hurricane or some other event, the application that we've built will present back the results of that and let the user then either QA it, override it, submit it back to be rerun. Every action that they're taking, we're actually storing the results of that into the GIS. And that presents a really interesting data set, because you can look back at the history of how did the machine learning system work, You know, what did it work well on? What did our users tell us about it? But we still get, you know, this final data set that we trust that we're going to use to make decisions from. So I'll just show you a little bit of some of the data that we collect in those environments. Similar to before, I'll just focus on the street level collections. I just want to, you know, present to you a little bit about how this works. You know, this is an example from the recent Napa fire we deployed with the local county. And in this case, they were performing damage assessment workflows, and they were deploying phones out to the field to do this. We deployed in support of that, driving the vehicles around in the scene, collecting the imagery, and letting their staff, you know, scale up because they could now sit and make assessments on this sort of imagery. This is the next area that's going to come from us, and I believe Esri is working in this area as well, is how do you enable the machine learning on the street level imagery? A lot of investment's gone on in the aerial space, but we're going to see huge advantages of what machine learning can do from the ground level photography. Okay, so just going to conclude our little presentation today. Really excited to get to show you a little bit about what we've been doing at Geocam, show you a little bit about the roadmap of what's coming in terms of, you know, how these different data sources are getting fused in and the different places inside of the ArcGIS platform that you can apply machine learning. It's really, really accessible today. We have some of the young folk that we've hired recently straight out of school who are using notebooks inside of ArcGIS Pro, and they're able to run existing models that have been created and get wonderful results out of it. So it's an extremely accessible system, and that's one of the things that we're most excited about in our partnership with Esri. Thanks, Todd.
Awesome. Thanks so much. Thanks so much, Miles. Yeah, great presentation. Yeah, so I guess as we wrap up here, any questions for Miles as we saw his presentation? All right. All right, so hearing none, we're going to take a 15-minute break here, and then be back here at 12:30 for an awesome presentation here from Esri, and we'll be back online in about 15 minutes. Thanks, everybody.